Imagine a hotel with infinite rooms. Not just a lot, literally infinite. Every room is occupied. No vacancies. And yet when a new guest arrives, the manager says, "No problem. We'll make space." This is Hilbert's infinite hotel, a mind-bending paradox proposed by mathematician David Hilbert to explore the strange nature of infinity. In the real world, a full hotel is full. That's it. But in this thought experiment, even when every room is taken, there's always room for more. How? It works like this. The manager asks the guest in room 1 to move to room 2. The guest in room 2 moves to room 3. Room 3 moves to room 4. And so on. Every guest shifts one room over, infinitely. Room 1 becomes vacant. The new guest checks in. Still full. But also, somehow, more full. Now imagine not one new guest but an infinite number. A whole new infinite bus of people pulls up. Once again the manager says, "Of course." This time, everyone currently in the hotel moves to a room double their number. Room 1 goes to 2. Room 2 to 4. Room 3 to 6. Now all the odd-numbered rooms are empty, and the infinite new guests check into rooms 1, 3, 5, 7. Magic? Oh. Just infinity doing what it does best. Breaking intuition. This isn't just a quirky math trick. It reveals something deep. Infinity doesn't behave like a regular number. Can expand without limit, absorb more without changing. You can subtract infinity from infinity and still be left with infinity. Or with nothing, depending on how you do it. That's not just weird. That's terrifyingly powerful. It challenges our understanding of space, limits, logic. What does it mean to run out, if infinity always has more? And if our universe is infinite, as some cosmologists believe, is it playing by these same rules? Can a universe already filled with galaxies still make room for more? Can infinite timelines shift to make way for new ones? Can you exist in more than one version of yourself without ever running out of space to do so? Hilbert's hotel doesn't have answers. It has doors. Infinite ones. Each one opens to a different way of thinking about the universe. About limits. About what full really means. Maybe. About how reality always finds room for one more impossible thing. Let's race into paradox. Achilles is fast, lightning fast. The tortoise? Not so much. But in Zeno's famous paradox, the tortoise gets a small head start in a race. Achilles takes off, confident he'll catch up in seconds. But logic, Zeno argues, says he never will. Here's why. By the time Achilles reaches the point where the tortoise started, the tortoise has moved slightly ahead. Now Achilles has to reach that new spot. But in that time the tortoise has again moved forward. It doesn't matter how fast Achilles runs, there will always be another tiny gap. Another fraction of distance to close. The logic seems airtight. Achilles must first reach the tortoise's last position, which is no longer current. So he'll never actually pass him. Of course, in reality, Achilles does pass the tortoise. We see it happen. Zeno isn't denying that. What he's doing is revealing a hidden tension between how we perceive motion and how we understand logic and division. Because what's really happening here is that infinity is messing with us. Zeno is dividing the chase into infinite steps. Achilles covers half the gap, then half of the remainder, and so on forever. That sounds like an infinite task. But here's the twist. Infinite steps don't necessarily take infinite time. The distances get smaller and smaller, and if the time to cross each shrinks too, the total time converges. It has a limit. It's not forever, it just feels like it. Centuries later, calculus solved the puzzle. Mathematicians showed that an infinite number of ever-shrinking steps can add up to a finite result. Achilles does pass the tortoise, but only because we understand how to sum infinity properly. Still, Zeno's paradox haunts us for a reason. Because it isn't just about a race. It's about the strange way reality unfolds. If space and time can be infinitely divided, is anything truly smooth? Or is motion just an illusion? A trick our brains play to stitch discrete frames into a fluid story? Modern physics suggests space might not be continuous. At quantum scales, reality might be pixelated, built from indivisible units like the Planck length and Planck time. If so, then Zeno's problem disappears, because you can't divide forever. There's a bottom floor. But until then, we're left with the haunting image. Achilles sprinting forever, always closing the gap but never quite reaching. An eternal chase across the endless steps of logic and illusion. And we wonder, is the world really in motion? Or are we just flipping through the frames one impossible step at a time? Picture this: a monkey at a typewriter. No training, no guidance, just pure random key smashing. Now imagine a second monkey, then a third, then a million, then an infinite number of monkeys typing on infinite typewriters for infinite time. According to the infinite monkey theorem, eventually, inevitably, one of those monkeys will type out the complete works of Shakespeare. Word for word, letter for letter, every comma, every pause, every typo, if there were one. Sounds ridiculous, right? But mathematically it checks out. When randomness is paired with infinity, the impossible becomes not just possible, but guaranteed. Let's break it down. There are only so many ways you can arrange letters on a keyboard. The chances of a monkey typing to be or not to be by accident are astronomically small. But if they type forever, every possibility will eventually occur. Infinite time equals every outcome. That's where the paradox hits. Infinity doesn't care about odds. It doesn't care about what's likely or meaningful. It simply plays out everything. Not just Shakespeare, but every book that's ever been written. Every book that could be written. Every variation of every sentence you've ever spoken, with one word changed. Then another version where just the punctuation is different. Most of what's produced will be gibberish, noise, chaos. But hidden within that chaos, every masterpiece, every prophecy, every possibility, it sounds poetic, until you realize what it really implies. Meaning can emerge from randomness, and that's terrifying, or liberating, or both. Because if infinite monkeys can create Shakespeare, then so can a mindless algorithm. Then maybe you, your thoughts, your ideas, your entire identity, could be the result of enough randomness run long enough. A lucky run of code. And if that's true, what does that say about creativity? About genius? About the soul? Or maybe this: the infinite monkey theorem doesn't devalue meaning. It reveals how rare it is. How precious. Among the infinite noise, something coherent, something beautiful, emerges. So maybe you're not a monkey typing at random. Maybe you're the one in infinity pattern that actually made sense. A spark of order in a sea of chaos. Imagine holding a perfect solid ball in your hands. Now imagine cutting it into pieces. But not normal pieces. Infinitely precise, abstract, mathematical pieces. Slices so bizarre they defy geometry as we know it. Then with just a little rearranging, no stretching, no adding, you reassemble the pieces into two identical spheres, each the same size as the original. You didn't duplicate it. You didn't scale it. You just doubled it. Welcome to the Banach, Tarski paradox. One of the most disturbing, reality-breaking results in all of mathematics. A paradox where 1 equals 2, and our intuition about volume, space, and matter collapses. Here's how it works. You start with a sphere. You divide it into 5 very specific, very strange sets, constructed using the axiom of choice, a controversial rule in set theory. These sets are non-measurable. They don't have well-defined volumes. You then rotate and shift the pieces and somehow end up with 2 spheres identical to the first. Not smaller. Not distorted. Exact copies. It's not magic. It's pure mathematics. But it's also pure nightmare fuel for anyone who believes in a physical, logical universe. Of course, in the real world, this can't happen. Atoms have limits. Physics prevents such precision. You can't slice molecules into abstract clouds of points. But in the realm of pure math, in the land where infinity runs wild, space can break its own rules. So what does it mean? It means our ideas of size and volume don't always apply in infinite or abstract contexts. It means that when dealing with infinity, intuition fails hard. And if reality is a simulation, this paradox raises even deeper questions. What if the space we live in is discrete, not continuous? What if our 3D world is built from units, tiny data points the simulation renders into geometry? Then maybe paradoxes like Banach, Tarski don't happen because the code won't allow it. The engine refuses to render non-measurable sets. But if we're living in a mathematical universe, one ruled by logic more than physics, maybe these kinds of impossible splits are possible at some level we can't reach. In higher dimensions, deeper code. And what if duplication doesn't require mass, just math? 1 apple, 2 apples, infinite apples. Not from farming, not from cloning, from logic. So here's the real question. If a single object can become 2, what else can be duplicated, split, copied endlessly? Matter? Time? Picture a trumpet, wide at one end, narrowing forever at the other. It stretches out infinitely, never quite closing, just tapering endlessly. This is Gabriel's horn, a shape formed by rotating the curve y equals 1/x around the x-axis, from 1 to infinity. The result? A horn with some truly weird properties. It has infinite surface area, but it contains only a finite volume. Yes, infinite outside but finite inside. Which means, in theory, you could fill it with a finite amount of paint. But you could never paint the outside because the surface area is infinite. You'd run out of paint before covering it. That's not just counterintuitive. That's a paradox that makes your brain stall out. How can something be infinite in one way but not another? Welcome to the world of calculus and infinity, where size gets slippery and logic bends. In the case of Gabriel's horn, the volume under the curve converges to a finite value as the horn stretches toward infinity. But the surface area? It keeps growing. Each slice of the horn is thin, so thin that adding up their volumes results in a small number. But the skin, the surface you'd have to paint, adds up differently. Grows forever. So in math, you can fill it but you can't code it. It's elegant. It's impossible. And it tells us something profound. Infinity is multidimensional. You can't treat it like a regular number. You can't assume that all infinities behave the same way. One aspect of a thing might be boundless while another is contained. Now shift to physics. What if parts of the universe work like Gabriel's horn? What if space is infinite in one direction but finite in mass? What if black holes or wormholes behave this way, storing finite energy in infinite curves? And if we live in a simulation, what if this shape is a trick of rendering? A compression tool? A cheat code? A way to simulate the illusion of infinity using finite resources? Think about it. A world that appears boundless but runs on a limited system. Like a game map that loops or narrows at the edges, giving the sense of endless space without the processing cost. Gabriel's horn isn't just a strange object. It's a lesson that sometimes you can fit infinity in a box, and sometimes the thing you can fill can never be fully touched. Look up at the night sky. Now imagine traveling beyond every star you see, past every galaxy, beyond every black hole. Keep going, further. Now ask yourself, does it ever end? If the universe is truly infinite, not just large but boundless, then something wild follows. Every possible arrangement of matter must happen somewhere. Which means, there's a version of Earth just like this one but with slightly different clouds. There's a version where you never broke that bone, never quit that job, never sent that text. There's a version of you that never existed. and a version that's lived this exact life, beat for beat, a billion times before. This is the paradox of infinite universes. The idea that, in a universe with no edge, no end, and finite building blocks, atoms, particles, physics, everything that can happen does happen, again and again. It's not just sci-fi. Cosmologists take it seriously. Some multiverse theories suggest that beyond our observable bubble, there are regions of space with completely different histories. Maybe even different laws of physics. And if that's true, infinite use might be the rule, not the exception. Here's where it gets strange. There's a version of this very moment happening right now, elsewhere in the cosmos. There's another version where you clicked off this page. Another where you're reading this in a language that doesn't exist here. In an infinite space, the improbable becomes inevitable. So what's the paradox? It's this. If every possibility exists, does anything matter? If you make a choice here and a different you makes the opposite choice somewhere else, does free will mean anything at all? Some find this idea comforting. Others find it horrifying. But either way, it humbles you. It forces you to ask, what is you in the face of infinite copies? And in a simulation, things get even more layered. Maybe these infinite versions aren't scattered across space, but across simulated layers. Copies of the same universe running side by side, each slightly altered, each spinning out new variants of reality. A stack of tapes, each labeled with a different version of your life. So here's the final thought. If everything possible is happening somewhere, why are you here in this version? What makes this timeline your seat in infinity? Cause and effect. One thing leads to another. That's how reality works, or at least how we think it works. You strike a match, it lights. You push a door, it opens. Something causes something else. But what if that chain never started? What if cause and effect looped forever, feeding into each other endlessly with no beginning and no end? Welcome to the infinite loop paradox. It's the idea that some events, maybe all events, don't start anywhere. They just keep causing each other in a perfect closed cycle. Think of it like this. A man travels back in time and gives his younger self a book on how to build a time machine. That younger version uses it to grow up, build the machine, and go back to give himself the book. Where did the book come from? Who originally wrote it? Nowhere. It exists only in the loop. A perfect, causeless circle. That's the paradox. The chain of cause and effect doesn't terminate. It spirals in on itself, eternal and closed. It's not just a sci-fi gimmick. In logic, mathematics, and even cosmology, we find loops that challenge the idea of origin. In some models of the universe, time itself might be a loop. The Big Bang births time, but time also gives rise to conditions that create the Big Bang. In the brain, feedback loops between neurons generate consciousness, but that consciousness then influences the neurons. In computers, a recursive process may define itself using its own output. At the heart of the paradox is a question that breaks philosophy. Does everything need a cause? Or can some things just exist in a loop? And in a simulated universe? This gets even trickier. What if the simulation isn't running on a straight timeline but a looped one, repeating itself, tweaking variables, learning from itself like a machine teaching itself how to think? What if you are part of a loop? The same thoughts, the same lessons, the same patterns, over and over and over, until you notice, until you break it. Or maybe there's no breaking it. Maybe noticing is the loop. So the next time you feel like you've lived a moment before or repeated the same mistake or been here already in some unspoken way, ask, is this déjà vu? Or just the latest rotation of an infinite spiral? At first glance, it sounds simple. Imagine a set, a collection of things. Some sets contain themselves, some don't. For example, the set of all abstract concepts? Sure, it's abstract. It contains itself. The set of all books? Not a book itself, so it doesn't contain itself. Now, British philosopher and mathematician Bertrand Russell posed a question that wrecked the foundations of logic. What about the set of all sets that do not contain themselves? Let's call it set R. If set R contains itself, then it shouldn't because it only contains sets that don't contain themselves. But if set R does not contain itself, then it should because that's exactly what it's supposed to contain. It's a trap. No matter what you choose, it contradicts itself. A logical paradox with no escape. Russell's paradox exposed a deep flaw in early set theory, the very system mathematicians used to define numbers, logic, and proofs. It's like discovering a glitch in the basic code of reality. This wasn't a minor issue. It was a crisis. Mathematics, it turned out, had a loop in its logic. To fix it, mathematicians had to rebuild parts of math from the ground up, adding restrictions, redefining what sets were allowed to exist. But the ghost of the paradox remains, haunting the edges of logic, whispering that some truths might always stay just outside the system. So what does this have to do with reality? Everything. If our universe is fundamentally mathematical or logical, if it's built on rules, systems, definitions, then paradoxes like this suggest limits. Points where logic can't go. Questions that logic can ask, but not answer. And in a simulated reality, Russell's paradox feels like a warning label in the code. Don't look too closely. Don't define too broadly. Some sets crash the system. It also has eerie philosophical echoes. What happens when the mind tries to understand itself? When the simulation starts simulating simulations? When a self-aware system begins asking whether it should exist at all? Maybe some loops aren't meant to be solved. Maybe some sets aren't meant to be opened. Russell's paradox doesn't break math. It reveals it, raw and strange and incomplete. Just like reality. Just like us. Stand between two mirrors. Look into one, and what do you see? A reflection of yourself. Then a reflection of that reflection. Then another. And another. And another, stretching into forever, getting smaller, dimmer, harder to make out. You're not just seeing a copy. You're seeing an infinite cascade of reality folding in on itself. This is the idea behind infinity mirrors. Not just a visual trick, but a metaphor for a universe that might be nested, self-referential, endlessly repeating. What if reality works the same way? A world inside a world. A simulation inside a simulation. A consciousness imagining itself. And inside that, another. And another. And another. Not just expanding outwards like the cosmos, but folding inward. Reflecting itself into finer and finer layers. Not zooming into atoms, but zooming into patterns of awareness. Reflections of reflections. It's not just poetic, it's mathematical. Fractals behave this way. Zoom into a Mandelbrot set and you'll see the same shape repeat endlessly. At every scale, the pattern re-emerges. Self-similarity. Recursion. Now apply that to existence. Your thoughts contain memories. Those memories contain thoughts. Those thoughts contain versions of yourself, thinking. Each moment reflects the last, shaping the next. So here's the question. Where's the bottom? Is there a final reflection? A core? A base reality? Or are we just riding a ripple in an infinite pond, one copy removed from the last? Even perception itself is a mirror game. Your senses reflect the world into your brain. Your mind reflects those signals into meaning. You reflect that meaning into decisions. Every level is observing the level beneath it, without ever quite reaching the source. And if you live in a simulation, it's even more literal. A universe rendered by an AI. That AI simulated by a higher civilization. That civilization imagined by another. A mirror. Inside a mirror. Inside a mirror. Maybe the simulation isn't a box you're trapped in. Maybe it's a hallway of reflections and you're one pane in an endless corridor of selves. And just like in the mirror, every version is you. Fading, creaking, echoing, but still there. Still watching. You invent a time machine. You travel to the past. You find your grandfather before he has children, and you kill him. Now the question, if he never has children, how were you born? And if you were never born, who killed him? This is the grandfather paradox, the classic time travel riddle that unravels causality itself. A perfect loop of contradiction. But what if the problem isn't time travel? What if the problem is assuming there's only one timeline? Let's step into the infinite. If time is a single fixed line, then changing the past creates a contradiction. You can't both exist and not exist. But if time is branching, if every decision, every action creates a new fork in reality, then the paradox vanishes. You don't destroy your timeline. You create a new one. In that new reality, your grandfather dies. You're never born there. But you came from a different strand, a separate line of cause and effect. The timelines diverge and each continues on its own track. This is the many-world solution to the grandfather paradox. Quantum mechanics already hints at this. Every possible outcome of a quantum event happens, but in different branches. Reality splits constantly, infinitely. Your time travel just pushes you into a different one. It's not a loop. It's a tangle of threads, all running side by side. Still, the paradox gets deeper. Because if you can hop timelines, what stops someone else from hopping into yours? What if someone from another strand is here now, shaping your present with actions that don't make sense in your history? Suddenly things feel familiar. Events that feel off. People who act like they remember something you never did. Choices you almost made but didn't, that still echo in your life. Maybe we're already living in collided timelines. Maybe time travel doesn't break reality, it just makes it more complicated. And in a simulation, time can be even weirder. If the universe is code, then time isn't a river. It's a variable. It can be paused, rewound, forked, rewritten. A save point. A reload. A branch. The paradox only exists if you assume the system cares about continuity. But maybe it doesn't. Maybe it runs all versions, simultaneously. So go ahead. Break the timeline. You might just create a new one. And somewhere, some version of you is already wondering, was this always meant to happen? Or did I just rewrite the past, again? Picture a lamp. At time 0 it's off. After half a minute you flip it on. After a quarter minute more, off again. Then on after an eighth. Then off after a 16th. You keep flipping the switch, each time in half the time as before. By 1 full minute you've flipped the switch an infinite number of times. Now pause. At exactly 1 minute, is the lamp on or off? This is Thomson's lamp, a paradox dreamed up by philosopher James F. Thomson in 1954 to illustrate the strangeness of performing infinite tasks in finite time. Logic collapses under the question. Every switch reverses the previous state. On off forever. But when the process ends at the 1 minute mark, there's no last switch. The sequence has no final action, so we can't say whether it left the lamp on or off. The lamp isn't on. It isn't off. Something else. Something undefined. That's the power of infinity. It doesn't just stretch space or time. It warps logic. What feels concrete, the lamp must be one or the other, melts under the weight of an infinite sequence. Now apply that to the world. Can you complete an infinite process? Can something be both finished and never-ending? Can motion, change, identity exist without a final moment? Physicists bump into this too. In quantum mechanics, there are systems that never settle. They oscillate endlessly. Some functions don't converge. They just vibrate at the edge of definition. And if the universe is a simulation, then Thomson's lamp becomes a bug in the system. A thought experiment the engine doesn't know how to render. A moment where binary logic fails. Maybe the simulation runs until it hits one of these paradoxes, then resets. Or maybe you are the lamp, flipping back and forth between versions of yourself, between timelines, between decisions, never quite landing, always in flux. always waiting for the final switch that never comes. So ask yourself, are you on? Or suspended between infinite flips of being and becoming? Take a coastline. From far away it looks like a simple curve. Zoom in and you see more detail: bays, inlets, jagged rocks. Zoom in again and those rocks break into ridges. Again, and the ridges break into grains, grains into atoms, atoms into quarks. Does it ever end? Fractals say no. A fractal is a pattern that repeats itself no matter how far you zoom in or out. It's self-similar, infinite in complexity. The deeper you look, the more you see. Mandelbrot sets, snowflakes, Romanesco broccoli, lightning, trees, lungs, blood vessels. Nature loves fractals. But what if reality is one? The fractal universe paradox suggests that the structure of the cosmos might repeat itself at every level. Galaxies resembling neurons, star systems like atoms, space-time rippling in recursive patterns from the macro to the micro. It's not just visual. It's structural. Some scientists and physicists have pointed out eerie similarities between large-scale cosmic webs and the networks inside your brain. Between cloud patterns and fluid dynamics. Between DNA strands and spiral galaxies. The code seems reused. If the universe is fractal, then you could theoretically zoom forever. No final pixel. No bottom layer. Just more detail, more depth, more echoes of the same. That's where the paradox begins. Because if everything is made of repeating patterns, what's original? What's foundational? Is there a smallest building block? A highest level? Or is it turtles all the way down and all the way up? Now add the simulation layer. Fractals are efficient. You can use a simple equation to generate stunning, complex imagery. A few lines of code to simulate infinite beauty. If the universe is simulated, a fractal design would be the ultimate optimization. Endless complexity, minimal resources. It would mean the world isn't copied, it's iterated. You're not just in the universe. You might be the universe folded into itself. And here's the kicker. If reality is fractal, then maybe consciousness is too. Thoughts within thoughts. Selves within selves. Each one containing another. A mind patterned after the cosmos. A cosmos patterned after the mind. So the next time you see a spiral, a snowflake, a branch, a storm, ask, what scale am I at right now? And what version of reality is looking back? Imagine this moment. You're reading these words. The screen, the room, the beat of your heart. Now imagine it happening again. And again. And again. Forever. This is the paradox of eternal return. The idea that, given enough time, the universe will repeat itself exactly, down to the smallest detail. Not metaphorically. Literally. Every thought. Every blink. Every choice. Over and over. In an infinite loop. Goes back to ancient philosophy. The Stoics believed the universe cycled endlessly. Friedrich Nietzsche later posed it as a terrifying challenge. What if you had to live your exact life again? Every pain, every joy, every mistake? Would you accept it? But modern physics gives it teeth. If the universe is finite in structure but infinite in time, eventually all possible configurations of matter will repeat. It's like shuffling a deck of cards. With 52 cards, there are trillions of combinations, but not infinite. If you keep shuffling forever, you'll eventually hit the same sequence. Now imagine the deck is the entire universe. Eventually, the atoms will align just like they did when you were born. And they'll do it again. And again. And again. It's not just a thought experiment. It's math. And if time has no end, the return is inevitable. So what does that mean for you? It means this version of you, right here, right now, might have lived this moment infinitely many times before. And might again. You may feel like you're making new choices, but they're old footprints, worn deep by repetition. The paradox isn't just that life repeats. It's that it repeats exactly, but feels new every time. Now zoom out. Apply simulation theory. If we're living in a programmed reality, maybe this version of your life is just one run-through. And the system has reset thousands, millions, infinite times. Maybe the simulation doesn't need to start over. It just loops, rewinds, loads your save file. Or maybe there are no new lives. Just this one running forever. Every fear, every regret, every joke, every love, on repeat. So the next time you feel a strange sense of déjà vu, when a moment hits you with an eerie familiarity you can't explain, ask yourself, have I been here before? And if I have, what would I do differently this time? Infinity. One word, one idea, one endless concept. Right? Not quite. In the late 1800s, German mathematician Georg Cantor shook the foundations of mathematics by showing something almost no one believed was possible. Some infinities are bigger than others. It sounds wrong. Feels wrong. But mathematically it's true. Let's start with a simple infinite set, the natural numbers. 1, 2, 3, 4, 5. Forever. This is countable infinity. You can list the numbers one by one even if the list never ends. Now take the real numbers between 0 and 1. Like 0.1, 0.001, 0.00000000003, pi/10, square root 2 halves, and on and on. There are infinitely many of those too. But Cantor proved that no matter how cleverly you try to list them, you'll always miss some. There's no way to match them up with the natural numbers one-to-one. The real numbers form an uncountable infinity, a bigger kind of endless. Cantor called these different sizes of infinity cardinalities. The countable infinity of natural numbers is called Aleph null. The infinity of real numbers is strictly greater, uncountably so. And there are even higher infinities beyond that. A whole ladder. An infinity of infinities. That's the paradox. Infinity isn't a ceiling. It's a staircase. No matter how far up you go, there's always another level. And if that's true in math, what about reality? Could different scales of infinity explain strange cosmological ideas? Why the multiverse might be bigger than we can imagine? Why some infinities loop while others branch? Why time or consciousness or possibility itself might exist on different infinite tiers? In a simulation, this becomes even more surreal. What if each level of the simulation runs on a larger infinity than the one below it? What if your thoughts are infinite, but still limited compared to the layer above? Maybe you're infinite, in a local sense, but zoom out and you're just a single number in a higher system. A finite figure inside a bigger endless set. Infinity isn't one thing. It's a structure, a hierarchy, a reality-bending truth that forces us to abandon intuition and embrace a logic that says, you haven't even begun to see what forever means. So here's the final question. If you're already inside infinity, how many levels deeper can you go? Right now you're reading this. But in another universe, maybe you stopped 2 sentences ago. In another, you never clicked the link. In another, you're not even you, you're someone else entirely living a different life. This is the unsettling heart of quantum infinity. That every choice, every quantum event, every flicker of uncertainty spawns a new universe. Welcome to the many worlds interpretation of quantum mechanics. One of the most mind-warping ideas in modern science. It says that reality doesn't collapse into one outcome. It splits. Endlessly. Infinitely. A photon goes left and right. Both happen. 2 universes. You get the job and don't get the job. 2 universes. You live. You die. 2 universes. Now multiply that by every atom, every particle, every quantum interaction across the entire universe, every second forever. That's not just infinity. That's exploding infinity. A fractal multiverse branching in real time. It's not metaphor. It's math. And it leads to a brutal truth. There is a version of you for every possible outcome of every possible moment. Not just a copy. A real version. Living a life you'll never see but might somehow feel. Ever get a strange gut feeling that you made a different choice? A deep sense that something could have gone another way and did? Maybe it did. Just not in this thread. Some physicists argue this isn't just elegant. It's the only way to explain certain quantum behaviors. Rather than particles choosing one outcome, the universe splits to accommodate all of them. Nothing is destroyed. Everything is preserved. So what does this mean for free will? Maybe it means you always choose, and every choice becomes real somewhere. Maybe you're not picking one future, you're birthing many. And in a simulation, this theory fits perfectly. Simulated environments already use branching logic. Games do it. AI models do it. Run a simulation with choice-based paths and you don't overwrite, you fork. You let all paths run in parallel. So maybe you're not in one version of reality. Maybe you're in your version. The one where you made the choices that brought you here. The other versions? Still out there. So here's the question. If every version of you already exists, what makes this one worth living fully? Step outside at night. Look up. Black sky. Dots of light. Quiet. Beautiful. But also strange. Because if the universe is truly infinite and stars are spread throughout it, then why isn't the sky ablaze with light? Why aren't we blinded by a wall of endless stars in every direction? This is Olbers Paradox, first posed in the 1800s, and it asks a question that seems simple but cuts deep. In an eternal, infinite universe full of stars, why is the night sky dark? Let's break it down. Imagine you're standing in an endless forest. No matter where you look, your vision should eventually land on a tree. Same with stars. If the universe stretches infinitely, then every line of sight should end with starlight. So the night sky should be bright. Not black. But it's not. Here's what science says. The universe isn't eternal. It had a beginning, the Big Bang. Light takes time to travel and many stars' light hasn't reached us yet. The universe is expanding, stretching light into infrared wavelengths, beyond our eyes. In other words, the darkness isn't empty. It's light we can't see. It's history still on the way. That solves the physics. But the paradox still lingers. Because even if the expansion explains the blackness, it also reveals something eerie. We're watching a sky filled with ghosts. Stars that no longer exist. Galaxies whose light has taken billions of years to arrive. What you see at night isn't now. It's a time-lagged echo of a universe that might be very different today. So what are we really seeing? Not the universe, but the rendered illusion of it, frozen in whatever light happened to reach us. In a simulation, this makes even more sense. Why render infinite stars in real time? Why not simulate just enough for the observer to perceive mystery? Darkness is efficient. Black pixels cost less. Let the player fill in the blanks with wonder. And what if the darkness itself is the boundary? Not of space but of awareness. Of what you're allowed to see. Maybe you're not looking at a starless void. Maybe you're staring at the edge of the dataset. The cosmic off switch. And in that sense, the dark sky becomes the biggest clue of all. Not a failure of the universe to light up, but a quiet whisper. This is all we wanted you to see. There's a point in space where everything stops making sense. Where gravity becomes so strong that nothing, not even light, can escape. Where time distorts. Space folds. Information disappears. This is a black hole. And at its core lies something terrifying. Infinite density. Called a singularity, it's a point where all the mass of a star, or maybe an entire galaxy, is crushed into zero volume. Not small. Not compressed. Zero. Which means, its density becomes infinite. And physics breaks down. Einstein's equations, brilliant as they are, can't handle it. The math explodes. space and time no longer behave. We can describe what happens around a black hole but not inside it. What lives beyond the event horizon? We don't know. And maybe we're not meant to. Here's where the paradox kicks in. Infinite density should create infinite gravity. Infinite gravity should warp everything beyond recognition. But black holes just sit there, quiet, hidden, still obeying cosmic rules. It's like the universe folded something impossible into a box and sealed it shut. And yet black holes are everywhere. They're not rare. They're common. At the center of galaxies, roaming space, even colliding, sending out ripples of gravity we can now detect. So what does that say about the fabric of reality? Maybe it's more fragile than we thought. Maybe reality tolerates infinity just barely. And in a simulation, black holes become even stranger. They look suspiciously like system errors. Areas where rendering fails. Where information is compressed or deleted. Where the engine can't calculate, so it collapses the space into a no-go zone. We know black holes consume data. But where does it go? Some physicists think the information is lost forever. Others believe it's stored on the event horizon, like a hologram projected from the edge. That's right. The inside may not exist. Just the boundary. Just the skin. A cosmic user interface. So maybe black holes aren't holes at all. They're storage. They're compression algorithms. They're clues. And the singularity might be a metaphor. A way of saying, beyond this point, your rules no longer apply. You look at a map of a country. The coastline winds along the edge, irregular but clear. You grab a ruler and start measuring. 1,000 miles maybe. Simple. Now zoom in. More detail appears. Tiny inlets, jagged rocks, hidden curves. Measure again with a smaller ruler. Now it's 1,300 miles. Smaller ruler? 1,800. Smaller still? 3,000. 10,000. 1,000,000. Infinity. This is the Coastline Paradox. A simple question that reveals something deeply strange. How long is the coastline of a country? Answer: it depends on how closely you look. The more detail you include, the longer the measurement becomes. Zoom in infinitely and the length approaches infinity, even though the area remains finite. It's not a trick. It's math. And it exposes a truth. The world isn't smooth. It's rough, jagged, fractal. And if you try to measure it with perfect precision, it falls apart. The concept was formalized by mathematician Benoit Mandelbrot, who used it to develop fractal geometry, shapes that repeat endlessly at every scale, just like coastlines, and clouds, and lightning, and blood vessels. So what's the paradox? That something finite can appear infinite, when observed in the right or wrong way. That complexity isn't just about size, it's about resolution. You don't change the object. You change how you look at it. And it becomes unmeasurable. Now apply that to reality. What else behaves this way? Time. Try measuring it in heartbeats versus atomic vibrations. Thought. Try analyzing a memory frame by frame. Identity. Try defining you without hitting recursive loops. Maybe the closer we look, the more we realize there isn't a solid edge, only an infinite unfolding. And in a simulation, this is a classic rendering illusion. A coastline that becomes infinitely long is a clever way to create complexity from simple code. You don't need a million miles of detail, just an algorithm that unfolds more depth as the user zooms in. Like digital textures, or procedural terrain in a video game, or the illusion of choice. Maybe the world around you isn't pre-built in detail. Maybe it becomes infinite only when you look too closely. And maybe that's the warning. Don't zoom in too far. You'll never find the edge. Because the edge was never real. Math is supposed to be perfect. A clean system of rules. A language of certainty. Something is true, it can be proven. Right? Wrong. In 1931, Austrian mathematician Kurt Gödel shattered that illusion. With two statements, short, sharp, unstoppable. Together they're known as Gödel's incompleteness theorems, and they reveal something terrifying. Any system complex enough to do basic math contains truths that are true, but can't be proven. Read that again. There are facts within a system. Truths we can feel are real, but we can never prove them from inside the system itself. Why? Because no system can contain its own truth. It can talk about numbers, but not truth about itself. To prove everything, you'd have to step outside the system. But if you step outside, now you're in another system, with its own limits, and so on. Forever. This is the paradox. A perfect system can never be complete. A complete system can never be perfect. It's like a book that contains everything, except the sentence that says, "This book contains everything." Or a mind trying to fully understand itself. Gödel's work collapsed the dream of building a flawless logical machine. It exposed the boundaries of knowledge, not based on ignorance or error, but baked into the structure of truth itself. Now apply this to reality. If the universe is mathematical, structured by logic, then Gödel's paradox suggests there are truths we'll never be able to reach from within. Not because we're too small, but because truth hides behind walls the system can't breach. It means there are questions we can ask that no answer will ever satisfy. There are truths about consciousness, reality, even physics, that live just beyond the line of provability. There may be no final theory of everything, just deeper puzzles. And in a simulation, this paradox might be the firewall, the ultimate safety net to keep you from breaking out. A self-contained system that can do math, render physics, evolve life, but can never prove it's a simulation, because that proof lives outside, in a framework you'll never reach, just like a character in a game can never read the source code. Or maybe, Gödel's paradox is the source code, a subtle whisper from the builders. This world is real enough to live in, but never real enough to master. Starts with a game of chess. The legend goes, a wise man invents the game and presents it to a king. The king is so impressed he offers the man any reward. The man makes a humble request. Place 1 grain of rice on the first square of the chessboard. Then double it on each square that follows. Seems simple. 1 grain. Then 4. Then 8. Then 6. By the time you reach the 64th square, the total number of grains is 18 quintillion 446 quadrillion 744 trillion 73 billion 709 million 551,615. That's over 18 quintillion grains. Enough to cover the entire earth in rice. Multiple times over. This is the grains of rice paradox. A perfect example of how exponential growth explodes into infinity faster than we can grasp. What starts as a small, sensible pattern quickly breaks reality. It's not really a paradox of math, it's a paradox of perception. Because our minds think linearly, but exponential growth moves explosively. Now take that idea further. What happens when you apply exponential growth to technology, Moore's law, AI development, simulation complexity, choices in a branching timeline, information stored in a fractal universe? Things go from manageable to impossible, fast. What looks like just a few steps quickly becomes unreachable, uncountable, infinite. This is how infinity hides in the everyday. Starts small, quiet, unthreatening. But with each step it multiplies and suddenly the system is overwhelmed. The storage breaks. The simulation chokes. The logic buckles. And in a simulated reality, this may be the edge condition. The moment when the rules crack. Maybe the simulation limits exponential growth. Maybe it resets or diverts you before you hit the breaking point. Maybe entire concepts, like time, memory, or replication, are throttled to prevent runaway expansion. Or maybe that's the challenge. To play the game. To build toward that 64th square and ask, What happens after the board runs out? Because the paradox isn't about rice. It's about how easily infinity disguises itself as routine. One square at a time. One choice at a time. One small doubling. Until the world explodes in numbers too big to hold. Let's follow the chain and see if it ever ends. Why is the sky blue? Because of how sunlight scatters. Why does sunlight scatter? Because of the atmosphere. Why does the atmosphere behave that way? And so it goes. Every answer leads to another question. Every cause has a cause behind it. Every effect is just another link in the chain. Welcome to the infinite regression paradox. The idea that every explanation demands a deeper one, and the search for truth becomes an endless fall into the abyss of why. It's not just annoying. It's destabilizing. Because if every reason needs another reason, then where does it stop? Is there a first cause? A foundation that just exists without needing anything else? Or, is there no bottom? This is more than a philosophical edge. It hits every major system of belief, science, and metaphysics. In theology, who created God? In cosmology, what caused the Big Bang? In consciousness, what observes the observer? In logic, what justifies the rules of logic? If there's no end to the questions, then certainty becomes impossible. Everything rests on something else, like standing on a ladder with no ground beneath it. That's the paradox. Nothing explains itself, and every truth needs a deeper truth. Then knowledge becomes a loop, not a destination. Now bring in simulation theory. If this world is a simulation, we ask, who built it? Maybe a future civilization. Who built them? Maybe they're a simulation too. Then who created that? And so on. And so on. And so on. Turtles all the way down. Maybe this isn't a bug. It's design. A recursive structure where there is no base layer. No real world waiting at the bottom. Just an endless hall of mirrors, each reflecting another infinitely. Or maybe reality has to loop. Maybe the simulation is self-contained and all attempts to escape it just lead back to the start. Like a game that reroutes you when you try to break the map. Some thinkers argue there must be a prime mover, a ground truth that needs no cause. Others argue that asking why might not always be meaningful. That the chain doesn't end, it just folds back on itself. So here's the question that never goes away. What started all this? And if the answer is asterisk, nothing, it just is. Can you live with that? But the Möbius strip says, what if those are the same side? It's a shape that embodies duality collapsing into unity. Two sides? Not just one. Two edges? Nope, just one unbroken loop. It looks simple, but it's a quiet rebellion against binary thinking. Now zoom out to reality. What if the world works like a Möbius strip? What if the boundary between body and mind, self and world isn't a boundary at all, but a continuous loop? What if consciousness and the universe are one twisted strip, appearing separate but fundamentally connected? What if time doesn't move linearly but folds back into itself? In physics, the Möbius strip hints at non-orientable surfaces, topologies that twist dimensions in ways that challenge our logic. In art, M.C. Escher explored its strangeness. In metaphysics, it's a symbol of oneness disguised as duality. And in a simulation, this shape is a perfect metaphor for a self-contained system. A world that seems to have an inside and an outside, but no clear way to exit. Every path leads back to where you started, only from a new angle. It suggests a reality that loops forever without ever repeating exactly, always curving inward. Maybe the simulation doesn't have an outside. Maybe the player and the game aren't two separate things. Maybe the creator is inside the creation, just on the other side of the same loop. So here's the twist. You're walking the strip every day, crossing boundaries that don't really exist, living a life that seems divided, but might be one seamless whole. The Möbius strip isn't just a weird shape. It's a mirror. It says, "Look again. What you thought was the edge was just the turn." You climb a staircase, turn a corner, climb more steps, turn again, more stairs, until, without ever stopping, without ever changing direction, you arrive right back where you started. You've ascended endlessly and gone nowhere. This is Escher's infinite staircase, inspired by the Penrose stairs, a visual paradox that shows a staircase looping in on itself, forever rising or falling in a closed, impossible cycle. It shouldn't exist, but your brain believes it anyway. Why? Because each step makes sense locally. The angles check out. Your eyes are fooled. Logic says you're going up, but globally you're stuck. You're trapped in a perfect loop of progress that leads back to the beginning. That's the paradox. How can every part make sense, while the whole makes none? This isn't just about a drawing. It's a model for reality, time, thought, even life. Ever feel like you're making progress, climbing, learning, changing, only to end up back in the same habits? The same thoughts? The same outcomes? Like life itself might be an infinite staircase? You rise. You fall. You repeat. And yet, every step feels necessary. Feels real. Like you're going somewhere. Until you look up and realize you've been here before. Now zoom out. In a simulated world, the infinite staircase becomes more than a visual trick. It's system design. A way to create the illusion of growth without the need for infinite space. A feedback loop that feels endless but is perfectly contained. A game mechanic. A dream structure. A loop you're meant to notice. Because maybe you're not supposed to escape. Maybe the point isn't breaking the loop. Maybe it's recognizing it and choosing how to walk it anyway. Escher's staircase dares you to ask, what if your highest goals are built into a loop? What if every effort to escape is just another turn of the spiral? What if the system was designed to hold you in motion, forever chasing up, forever avoiding stillness? So here's the real test. Can you see the loop and still keep walking with your eyes open? You flip a coin. Heads. Tails. Heads. Tails. Totally random. Or is it? Now imagine you flip that coin not 10 times, not 100, but forever. An infinite series of random results. What happens? According to probability theory, something amazing and unsettling begins to emerge. Every possible sequence of flips will eventually appear. Yes, every sequence. All heads. That's in there. Heads, tails in a perfect loop? Yup. A string that exactly matches your DNA sequence encoded in binary? Somewhere in that infinite list of flips. Guaranteed. This is the infinite coin toss paradox, where pure randomness leads to perfect structure, not by design, but by inevitability. Here's the mind bender. Randomness, when stretched to infinity, creates order. It's not just probable, it's mathematically inevitable. Given infinite time, a fair coin will produce every finite sequence of heads and tails an infinite number of times. But here's the twist. You'll also get chaos, strings that look structured but aren't. Patterns that fool you. Runs of heads so long they feel intentional. Coincidences that seem meaningful. But they're not. They're just part of the noise. So how do you tell the difference between signal and random perfection? That's the paradox. Now apply this to reality. What if life is an infinite coin toss? Every moment a flip. Every choice random, or appears to be. Patterns emerge. Stories, logic, history, identity. But zoom out far enough and maybe it's all part of a vast, infinite sequence of outcomes. Some of which feel exactly like this. Even consciousness could be an emergent pattern, formed not by intention but by statistical inevitability in a vast enough system. And in a simulation, the coin flips become lines of code. Random number generators. Simulated entropy. A massive string of results playing out on an invisible timeline. Maybe this version of you, this moment, is one of those perfect patterns. A sequence of flips that, by sheer probability, resulted in a world that works. Maybe we're just the outcome of an endless computation, and every possible version of you exists somewhere in the stream. So here's the question. If randomness can eventually produce anything, is this life an accident? Or are you just the pattern lucky enough to notice itself? Imagine this exact moment. You right here, reading, breathing, thinking. Now imagine the universe rewinding. Galaxies contract, stars dim, particles shuffle, time rolls back. Then after enough time, this exact moment happens again. Not a version of it. This one. Same thoughts, same heartbeat, same glitch in the light on the wall. All of it repeated. This is the mind-blowing idea behind the Poincaré recurrence theorem, a mathematical concept that says, in a finite system with conserved energy, if you wait long enough, the system will return arbitrarily close to its original state. Given infinite time, it will do this infinitely many times. Translation: if the universe is a closed system, then everything that has happened will eventually happen again. And again. And again. Not because of magic. Not because of fate. Because of math. This isn't some mystical loop. It's cold, hard recurrence. It's physics saying, there are only so many ways the particles can rearrange themselves. Wait long enough and they'll repeat. It's like shuffling a deck of cards endlessly. Eventually the exact same hand will appear. Then again. Then again. But the paradox is this. If everything repeats, then what does choice mean? What does time mean? What does you mean? If your life is just one state in an eternal cycle of recurrence, are you really living it for the first time? Or are you walking a path you've walked before countless times, thinking it's new every time? It's Nietzsche's eternal return with scientific teeth. And it messes with the idea of progress. Because if everything loops, there's no forward, just different angles of the same spiral. Now apply this to a simulation. What if the system doesn't need infinite storage? What if it just reuses states, replays scenarios with slight variations or none at all? What if you're in a recurring simulation right now? A loop not of code but of initial conditions playing out again and again, like a cosmic playlist set on eternal repeat. And maybe the glitches, the déjà vu, the weird familiarity, that's the system catching up. So the question isn't just, will this moment return? It's, how many times has it already happened? And, will you do anything differently this time?